Topic is electric current. So hello friends, welcome to my channel. I'm in Question Center. Today I'm going to explain you 10th standard science chapter 12 electricity. So first of electricity, so let's come to the electric current. Electric current and circuit is our first topic. Electric current and circuit is our first topic. Let's come to this. So as you all know the charges flows the charges flows in a conductor. We say electric current is flowing. Charge means current only, no, current is flowing, we say. We know the cells provide the flow of charge from charge to glow a bulb. If a bulb is glowing, bulb to glow a bulb, the current is flowed to it and then it glows, as you know. When we switch on the current, the bulb glows. This why glows, because so switch the when we switch on switch that connects the link between the cells of current and cells and the bulb. Between the cells and the bulb, it connects the link. electric current means electric current means electric current electric current, a continuous and closed path of a circuit. Continuous and closed path of a circuit. It is closed path and continuous and closed path of a circuit. We can call it as electric current. The match is for 1 marks. Electric current can be said. Electric current can be expressed. We can say it by expressed by amount of charge. Amount of charge flows in a circuit. In a circuit, the amount of charge that flows. Electric current is considered as flow of positive charge in the positive direction, in the direction of current. So in an electric circuit the flow of electric current opposite to the direction of flow of electric current should be opposite to the direction of flow of charges. The electric current should be opposite when the charges flows, then it is negative charge. We can say that is negative, it is having negative charge. Otherwise it is having positive charge, we can say. The net charge q, it is said as q, and q it is pq, and time, it is by time t, current is represented here as I. So formula for this is electric current is I is equal to q by t. Sorry, not q by t. Net charge by time taken, or time. So the SI unit of electric current, the SI unit for electric current is coulomb. So coulomb, coulumb, coulomb, the SI unit. They may ask what is the SI unit of current means coulomb. that is denoted with capital C, and the charge contains in a circuit contains is 6 into 10 to the power of 1 10 to the power of 18, the charge that contains. So an instrument ammeter measures the electric current. The electric current is measured by ammeter. By which electric current is measured means ammeter it is. It is always connected in series. The ammeter is always connected in series. Connected in series. It is ammeter is always connected in series. This electric circuit, here you can see here there are bulb, ammeter, current, and positive and negative charges. Switch it is there. The dot symbol is switch, and this is a circuit we can say. Or so next is, this is one small question. This is a small question they will ask in some final exams. They will ask a question. Some questions are there in electric current. What is that means? So a current as 0.5 ampere, A means ampere, is drawn by a filament of an electric bulb for 10 minutes, and find the amount of electric charges that flows in the circuit. So they given that I means what I said. I means the electric current. The electric the electric current, that is 0.5 a 5 ampere we should say that, and the time they have given is 10 minutes is equal to 600 second 10 minutes. So we have to found q means the net charge. So to found that we have to multiply I into t, that is 0.5 ampere into 600 seconds. We have to multiply that time we will get 300 coulomb. So that is the answer for net charge. So this formula I is equal to q by t we have to use to form the net formula, to find the current answer. Electric current that is flowing in that. So next topic is electric potential and potential difference. Potential difference. In an electric circuit, or circuit means this I said no. In an electric circuit and in a copper wire. So current passes in a copper wire, as you know, copper wire. How the current passes, you may have doubt. Take an example. There is a tank. You are trying to take water. So one end of pipe is put to tank, and another to another side where you want to take the water there. So what happens when the water comes? So how the water comes? By the force, or force not, more by the pressure it will come, because there will be more pressure to come out. The water is more, so it will try to come out by pressure. Electrons will move. The electrons will move if there is electric pressure, means if there is pull, or because if there is pull, electric pressure, then only the electric charges will move. So electric pressure is there, then it will move. That is called potential difference. It is called as. Potential energy formula is potential energy that is denoted by V, by capital V, is equal to work done, that is W, and by charge, or by slash we can put slash charge that is denoted with Q, capital Q, that is V is equal to WQ. Like that only the potential difference that is having 1 joule and 1 coulomb, 1 joule and 1 coulomb, as 1 volt is equal to 1 joule by 1 coulomb. The joule is the scientist who found that. SI unit for that is, and the SI unit for potential or electric potential is, or potential current, electric potential is V or volt. V, or we call it as volt it is called. This is another problem on the same on the potential energy what I said. So there is given that 2 coulombs having potential difference of 12 volts. So we have 12 volts into 2 coulombs to find the W or work done we have to find. So W is equal to V by Q, means volt by coulomb, or it is called as Q, it is denoted sometimes Q. So we get 24 joule, that is the work done for that. Here they asked work done, so we got the work done. To find work done we have to do V into Q, and here to find the flow of charges we have to do Q is equal to I by T, or I is equal to Q by T. For Q is equal to I into T, but for sometimes we'll do I is equal to Q by T. Sometimes if they have given in question the T and Q and they have not given I, but here they have given I and T but not given Q, so we have to find that Q. So this is the next problem. Next is electric circuit. Electric circuit not circuit diagram. So circuit diagram, it has a battery, it has cell, it has plug key that we plug, and it has connecting wire, the wires that connecting wire, and symbols that are commonly used in an electric circuit. So an electric cell it has positive and negative. The big one is positive and the small one is negative. And a battery, so the battery is used in a cell. And a plug key, as I said in a circuit diagram, the plug key is used. So this is a plug key, and a plug key with closed plug key, that is open, this is closed, and a wire joint. The wire joint, they may ask to draw any one diagram from this, and this is electric bulb, wire crossing without joining, and this is ammeter, that is a plus point should be in the left side and right side minus, and voltmeter also same. And this is the variable resistance I will explain. And this is the a resistor, or resistance also we call resistor of a resistance. So there is difference between resistor and resistance. I will explain that in the when I am explaining resistance. So this is the symbols that we use in a circuit diagram. So next topic is the the Ohm's law. The Ohm's law. The Ohm's law is our next topic. So this is our next topic, and these symbols you have to keep in your mind. They may ask for 1 or 2 marks. Draw any. And so they may ask draw the resistance, electric wire or wire joint, wire crossing or ammeter, key. So they may ask anything, and this will help you in drawing a circuit diagram. These are the symbols we use in circuit diagram. As I said, the plug key, the battery, and resistor and resistivity. I will explain, and ammeter, as I said, and the voltmeter, and the current, battery. So they may ask this, so keep in your mind this all and diagrams. So next is the Ohm's law, called the George Simon Ohm. A scientist called George Simon Ohm. For he found the relationship between the current I, that is current symbol is I, as you all know, current I and the potential difference, relationship between the current and potential difference across its terminal, its near terminals. What is the difference he founded? And the potential difference, that is V terminal, and the potential difference, and the potential difference, that is V, potential difference V, we call it as the V, across the ends of wire, he said, across the ends of wire, that is wire in electric current, across the ends of wire in electric current. What happens means, in electric current, that is directly proportional. He said that that is directly proportional. He said that it is directly the potential difference and the relation between the current and potential difference across the terminals, and the potential difference in the wire, potential difference across the wire in an electric current, that is directly proportional. He said that is directly proportional to the flow of current in it, and you should not miss this if they ask Ohm's law. And it is provided its temperature remains same. So don't forget this, temperature remains same. If you miss this, the sentence will be changed. And this is the Ohm's law. In the other words, we can say that V into I, we can say that V into I is equal to constant, that is we can take as R, constant, that is or we can take it as R, or we can write as V, the potential difference, is equal to current by I into R, we can say. So like this he called that. So the thing that stops the flow of charge, in a current flow of charge in a circuit, the thing that stops it is called resistor. And resistance, or resistor, called as resistor, and the resistance is R. As I said, R is a constant, as I said, constant for the given metallic wire, or is a constant, as I said, metallic wire, or is constant, as I said, metallic wire at a given temperature. So metallic wire that is at a given temperature is called its resistance. If the constant for the given metallic wire in a given temperature, at a given temperature, then we can call it as resistance. And for that, the formula is So its SI unit is the SI unit of ohm is SI unit of ohm is in the Greek letter, that will be, I will say 1 minute. So after that, next is the ohm. Next is so the resistance, it depend on depends on the on its length, it depend, and on its area of cross section it depends, cross section, and on its nature, on the nature of the material, on the nature, what is the nature of that material, on that the resistance depends, as well as on these things it depends. And tables tells you the electric resistivity of some substance at 20 degrees Celsius, that are some conductors, alloys, metals, on that the way it will say. So after that it will say as about that. And so on this the resistance depends. So I explained one page, I explained a little bit more. So next is after this, then after this resistance factor, this is the factor that depends on the resistance factors. These are the factors, they may ask this for tomorrow, factors that depends, factors on which the resistance depends, resistance depends, they are these. So if they ask for 2 to 3 marks, so on which factor the resistance depends, you have to write this all. These are the sums they have given in your textbook. So let's come to the first sum. They have said that how much current will an electric bulb draw from 220 volt if the resistor of the bulb is 1200 ohm. This is the symbol of ohm. And how much current will an electric heater coil 220 volt source if the resistance of the heater coil is 100 volts. So now they have given V and R. Now they have given, so I is equal to V into R, V by R you all know. So let's divide 220 volts by 1200 ohms. So nearby we'll get 0.18 ampere. That is the answer for current that is in that ohm. And next is the same. They asked V by I is equal to V into R. That is we get 2.2 ampere. So like that only do all the other sums. That this only do all the other sums. Next is there are some sums in your textbook that all you practice like this only, the keeping remember in the formula, V formula, and the potential difference formula, and the power potential difference per volt, V into Q, and the current formula, that is Q by T, that is Coulomb net rate by time. Like that only keep that in formulas in your mind and answer these questions they have given. Next is resistance of a system of resistor. Resistance of a system of resistor. So the current through a conductor. So in the current in a conductor it depends on the resistance and potential difference. In resistance and potential difference, the current difference across its ends, it depends. And there are some of the gadget, so you have to show that. So no difference, and show that the circuit has three resistors, that is R1, R2 resistor is R1 and R2 and R3, and they are joined end to ends in a series. You have to show it. So if they ask like this question, what you have to do means this, you have to draw diagram. The resistor R1, R2 and R3 should be there, and ammeter should be here, and the switch should be here, and the current should be passing. Symbol you should put, and you should write I, otherwise there will be mistake happen, they will not give marks. Current is also main, and here you have to put voltmeter. That should be written like this only, resistance. After at the ends of the resistance, the voltmeter symbol should be written. So resistor in a series. What is resistor in a series? See here, all are joined one after one. They are joined one after one. There is no gap or big huge gap, or there is no difference. They are one after one only resistance. It is after one resistance.